Hello all. So last time we discussed the mesh current method. This is assessment problem 4.2 4.12, and in this circuit we have to find out the power dissipation in this 1 ohm resistor by using the mesh current method. So this is a circuit, and again we can see that here we have to identify the meshes which are present in this circuit. So the first mesh here is this one, the second one is this, and the third one is here, this one. So we have to consider basically three currents here. So the first current, I am again denoting it with the red color. So the first color current here is this I1. The second current is denoted by the blue color, which is here again I2, and the third one is denoted by the green color, which is here I3. Okay, so now we have these three currents here, but we can see here that here we have another scenario in which a current source is occurred between the two meshes here. So this is basically a branch in which both the currents I1 and I3 are flowing, and we have this current source here. So we can see here very easily that the value of I1 minus I3 is equal to the 2. Okay, why is this? Because the current in this branch the currents in this branch are basically I1 and I2, and the direction of the net current is basically the in the clockwise direction. Therefore we assume that the value of the I1 will be positive and the value of the I3 will be negative. Therefore we have written it like this one. Similarly, it can also be, if we write it in terms of all the three currents, this can also be written like I1 plus 0 I2 minus I3 equal to 2, and let me call it equation number 1. Okay, so this is my equation number 1, and here we can see that all the three currents are present. Okay, so now as we have considered this current source, now we can remove this one, and this circuit now we have will be like this. Okay, this will be my circuit here. This is the 6-volt voltage source. This is the 10-volt voltage source, and similarly here we have this 2 ohm resistor, 1 ohm resistor. Similarly here we have this 2 ohm resistor, and we have made this current source as an open circuit here. And when we consider it as an open circuit, now again we have this is 2, this is 2, this is 2, this is 10, and this one. Again we have three currents. The first one is here, the second one is here, and this one is the third one. Okay, so this is the third current. So now what is this? This is now our, this whole is our super mesh. Okay, so this is our super mesh. So now considering this super mesh first, so considering the super mesh first, okay, and applying KVL in the super mesh. So in the first sub mesh here, let me denote it by the red color. Here we have the voltages. Okay, so the voltages here will be the V10, which is the voltage rise, is equal to the V2, and similarly the voltages here, let me denote them with this green color. So these would be the V2 plus v2. Okay, so this v2 and this v2, these are two v2 voltage dissipations here. So now let me write them. So this is now actually the voltage source. This is 10. Similarly, the v2 here, two currents are flowing through this resistor, which are i1 and i2. So let me write it like 2 i1 minus i2. Similarly, now moving towards this 2 ohm resistor. So now this is 2 multiplied by the i3 minus i2, and similarly the last one, which is this one, so this would become 2 i3. Okay, so now this is our whole equation. So let me write it with this black one. So this is 10, this is 2 i1 minus 2 i2 plus 2 i3 minus 2 i2. Okay, and plus 2 i3. Now writing them again and adding all the similar terms, this would become 2 i1, and this is the i2, this would become minus 4 i2, and again the 4 i3, this is equal to 10. Okay, this is equal to 10, or taking 2 common here from this one and then dividing both sides by 2, I will get the i1 minus 2 i2 plus 2 i3, this is equal to 5, and let me call it equation number 2. So this is my equation number 2. Okay, so I have solved this one. Now let me consider the mesh number 2, as we have tackled down the through meshes which are 1 and 2. So now considering the mesh number 2 and applying KVL here, we can see here that the values here would be V6 is equal to, as this one is the voltage rise here. Similarly, so this one V1 plus V2 plus V2. Okay, so now writing their values here, this will be 6 equal to this is 1, so 1 multiplied by the sole current which is flowing through this one, which is i2, and similarly the v2 here is this one, so this is now 2 multiplied by i2 minus i1, and similarly this 2 here, so this is 2 multiplied by the i2 minus i3. Okay, so now rearranging them, I will get i2 plus 2i2 minus 2i1, and similarly plus 2i2 minus 2i3, this is equal to 6. Okay, so now adding all the concerned terms and rearranging it, so I will get here minus 2i1, similarly this and this plus 5i2, and now this one as minus 2i3, this is equal to 6, and let me call it equation number 3. So now we have, this is the equation number 3, this one was the equation number 1. Okay, so now you can see that I have three linear equations. So we have basically developed a system of linear equations, and we can solve this linear system of equations by using any method, whatever you like. So the three equations here are basically the i1 plus 0 i2 minus i3 equal to 2. Second one here is the i1 minus 2i2 plus 2i3 equal to 5, and the third one was minus 2 i1 plus 5i2 minus 2i3, this is equal to 6. So now we have this system of linear equations. We can solve it by many methods. Again, I have solved it by using the Wolfram alpha. So Wolfram alpha is basically the online framework or the Wolf online resource for solving any system of linear equations. So okay, so I have used it, and after solving all these three equations, I have found out that the value of I1 was 7 amperes. Similarly, the I2 was 6 amperes, and the value of I3 was 5 amps. Okay, so this is the solution of this linear system of equations. So now, as we can again revisit the statement of this question, here we are told to find out the power dissipated in the 1 ohm resistor. Okay, so this one is the 1 ohm resistor, and we can see here that the the current which is flowing through this resistor is this I2. Okay, as we know the value of the current which is flowing through this resistor, and also the value of the resistance is also known, so we can easily find out the power dissipation across this resistor. Okay, so the value of the power dissipation which is dissipated which is consumed by this resistor can be find out by using our equation, which is this is the 1 ohm. So this can be find out by using the I square R. We know the value of I here? Yes, we know it because this is I2, and the value of resistance here is 1, so the value here is this one, and P1 is equal to now 36 watts. Okay, so that is the answer of this question. So you can see here that what was the sole purpose of solving the questions like this one. If we have any current source between two meshes, so if we have a current source in a branch which is shared by the two meshes or two sub meshes in a circuit, those circuits can be solved by using the super mesh method. And you can easily see here that the availability of a super mesh can simplify any question. The solution of any question can be simplified by if we have a current source between two meshes. Okay, so that's it for this question, and I will solve more questions, more assessment problems, and more exercise problem of this chapter. And thank you so much, and I hope it will clear your concept. Thank you.